architecture of the Kubernetes, how Kubernetes is providing us the service. So I will start from what we did so far. We had a server, and in this server, what we did, we ran different containers. Different container ran with different services, and they interact with each other by using a network, different network. Okay, now we want to create. Now this server resources are 100% occupied. What you will do, you will create one more server and you will set up containers in parallel to this container, this server, and the other containers will run in this container. So each server will have its own network, and these containers can talk with each other within the server, but they cannot talk across the server like this. Okay, there is no communication channel across this, because how the traffic is going out to your if I quickly give you a review, there is a virtual switch, there is a virtual switch, these containers are connected with this virtual switch, these are with this virtual switch, this is connected with its physical network, this is connected with its physical network. In your physical environment, there is again a physical switch, and this is going to cable is going to this, and then network cable is going to this switch. So the outward traffic is all based on NAT and PAT. I mean, when you go outside this network, you can go by netting. So by using netting, you cannot land your traffic by using this whole network to this container. Okay, you can do the port forwarding, and you can tell this container to reach this container by using this machine physical IP and this port. Okay, this container can reach, but this is not the proper way how many port forwarding you will do. This is not an easy job. Okay, and second thing is and the orchestration in case you lose your whole server. The server is crashed. What about these containers? So these are some issues that we cannot fix with the simple Docker service. So for that reason, we must have to use some orchestration tool. And Kubernetes is the orchestration tool we can use to answer all these questions. A lot of other functionalities it will provide. All the SSL related questions you ask will be answered by Kubernetes, the reverse proxy and the security and connectivity of the containers across the different network, and up to layer 7, you can put the security for your application. So everything is possible. So this Kubernetes was initially was designed by Google. So the concept of namespaces arises, and it gave the birth of containers. They initially start using container, and then they found a limitation. Then the Google built the Kubernetes. So Kubernetes, why they built the Kubernetes? Because they had a lot of applications running, and they need they had a requirement uh, to make a high available environment. For that reason, they start building the Kubernetes, and later on they make this project open source. That's why it's very successful, because of the open source. A lot of people, communities are making changes, development in these Kubernetes projects. So Now Kubernetes is one of the best orchestration, not I will say best, is the only orchestration tool in the domain of microservices. Okay, so how this Kubernetes is working? Uh, just focus right now on these two green worker nodes. Think like these worker nodes are just like this diagram. These are the two worker nodes. Both are running with their own containers. So what we did when we set up the Docker, we simply install the Docker by using these commands I showed you. Just let me, yeah, these packages we installed. In this package, we install container DIO. Container D.io is basically the core engine that is responsible to run your containers. This is the engine, okay? And Docker is basically a wrapper in front of container DIO. When you run the Docker uh, PS or Docker images or Docker run, Docker execute, this is actually pointing to this backend engine. This engine is running your container. There is a wrapper in front of this container DIO. So Red Hat create its own wrapper with the name Podman. They are also using container DIO on the backend. Okay. So when we will install the Kubernetes on the worker node, you can see here container runtime. This is the container runtime. And container runtime is container d.io. And here you can see the red dots are basically the containers. Okay. So when in Kubernetes, when you are running the container, each container run in the form of pod. A pod can have more than one container, but remember when we are going to use Kubernetes, we will not use the word container. We will use the word pod. Whenever we have to launch a new service within the container, we will launch the pod. A pod can have more than one container, at least one container will be there. So what we will do, we have to install some runtime engine that can create the containers. And for that reason, we will use container d.io, whatever I showed you here, this one. Okay, so now we have a container runtime engine. We can run the container, but we don't have any wrapper in front of this runtime engine. We use Docker wrapper in front of this container DIO. But in Kubernetes, we will not have any Docker command. We will have a CRI-CTL, Container Runtime Interface Control command. The same command that will be CRI-CTL PS, CRI-CTL images. Okay, the same command we can use. This is a container runtime interface. So you can say this container runtime interface is just like the Docker. And this Docker is using container runtime engine, the container d.io. So, but in Kubernetes, we will not use Docker. We will use CRI-CTL utility that will interact with container runtime engine, and it will pop up all our new containers or manage all the containers. Same on the right side, you can say the same architecture. If you understand this portion, container runtime interface. So far what we did, we just work on this part. If I just segregate this portion, so far what we did, we just work on this portion. Okay, this container runtime interface, we use Docker and we create the containers. Now, all the things above to this architecture, is Kubernetes. So in the worker nodes are basically your nodes that are actually responsible to run your containers, your applications containers. And each worker node has a service named kubelet. Each worker node has a service named kubelet. This kubelet, you can see its arrow is going to container runtime interface. Actually, in Kubernetes, we are not going to run the commands like Docker run or CRI/CTL run. Kubelet will interact with container runtime interface and will launch the containers. So kubelet is basically the core engine running on each worker node that has the responsibility to launch the containers and report the containers that are not running. And now if you go further back, who is instructing to kubelet? This kubelet engine is instructed by whom? If you follow this arrow is going to API server. And this API server is actually running inside your control node. Control node, you can say your master node. This master node is basically the core engine that is administrating all your Kubernetes cluster. Kubernetes cluster mean all your worker nodes. So this controller node basically has 4 core components that are doing the complete administration and all the benefits we are getting from Kubernetes cluster. So it has API server, it has, so I will give you the explanation step by step if it in the format of the workflow. This is the admin user, this is the developer user, any user. We all as a human, we all as a human will interact with the Kubernetes cluster by using API server. And you know API is HTTP based request, HTTPS based request. So first of all, we need a secure communication. So we will set up some SSL certificates to make this API server reachable outside for the administrator, for the end users. And user mean not the application user, the cluster user who are going to launch the new application on in the cluster. So they will interact with this API server, and you know the security is mandatory. So there will be some credential-based authentication or token-based authentication to get into this cluster. So there will be a way we will discuss in detail, but just remember these admins and all the end users will interact with this API server using some token or secure method using transport layer security, the SSL based security. I mean, every data that is leaving your computer and reaching to your API server will be encrypted. So now you as an admin ask Kubernetes cluster, I need these number of containers running in up and running. Okay, you send the request to the API server. How that request you will send, for example, I am speaking with you in English. You can understand the English. I can speak with you Urdu, whatever language you can understand. I can speak. So there will be a language of communication with this API server that is known as manifest. Just remember this keyword, manifest. So administrator will write a manifest language and will throw the request to API server in the form of manifest. And API server will receive that request, and then it will ask the scheduler. It will ask the scheduler, okay, I got this request to set up this much of container, this much of pod, application server, database, whatever. So what should I do? The scheduler actually has a complete picture gain from the API server by kubelet. Kubelet after every some time is acknowledging to API that this much resource I have, CPU, RAM, disk, this much load. Right now I am managing this number of pods, and scheduler knows all this story, that what is going on, what is happening on these worker nodes with the help of kubelet. So scheduler will knows everything, and scheduler will acknowledge API. Okay, you can go ahead to worker node number 45 and set up these pod. Rest of all remaining, for example, you have to set up 9 different pods. So 3 you can do on worker node 45, 2 on worker node 3, 5 on worker node, that specific worker node. It will acknowledge. Then API server will request kubelet. Okay, I got acknowledgement from Skyler. Please go ahead and set up these containers. Okay, that request will go to kubelet. Kubelet will send the request to container runtime interface that we use so far, and it will create the container in the form of pods. When these pods will be up and running, it will pull the image from the internet, whatever. When these pods will be up and running on those specific worker node, the kubelet will acknowledge back to API server, okay, I did the job you asked me, and it is up and running. The API server will send that updated record in the etcd. Etcd is basically a database. So whatever is running inside your container, what you resources you created are recorded inside this database. Okay, so this database knows everything. So etcd is a key value based database. Just read this etcd database on Wikipedia. Okay, so far we understand API, scheduler, etcd. Any question? And kubelet and container runtime interface and container runtime and pod. So any question about these components so far? Okay. So now,
This
yeah,
controller manager is actually the master node. I mean, what would you say this controller? What is the core responsibility of this controller manager?
we have not discussed the controller manager so far. We just discussed API, scheduler, etcd, kubelet, container
Okay,
runtime,
okay,
container
sorry.
runtime. Okay.
Okay,
So
okay,
now this
sorry.
container manager, I was going to this one.
Okay,
Actually,
sorry.
this, no problem. This controller manager, I am going step by step. How in actual life the flow of data is going on. That's why. Now,
For ask,
yes,
yeah,
yes.
yeah, the API server request to the kubelet and get the ports information. So why
Hmm.
why the kubelet is there, and we will directly talk with the API can directly talk with the container RTI or CRI.
Is yes, it can be, but actually, this thing that I copied separately, it can be anything. You know how many container runtime are available in market? There are different container runtime provider. This is an engine. So Kubernetes cannot add the functionality of reading of in the API to talk with all type of container runtime engine. It is difficult job. You got the answer, or
Yeah, yeah,
so
yeah,
that's
got it.
why they set up a intermediary engine that name is kubelet. So now kubelet they are making intelligent, mean when you will set up the Kubernetes, so you will read the Kubernetes documentation. Okay, this type of container runtime engine you can use. Kubelet has the tendency to talk this type of container runtime engine. Okay, go ahead. For example, you install some container runtime engine that is not supported by Kubernetes, it will not work. So to make the thing simple, they just set up this kubelet. Kubelet is not only setting up the container and pod, it is also make acknowledging the complete health back to API.
Good.
Okay. So now pod is scheduled. Now this controller is doing the core, you can say the benefit we are getting from Kubernetes. For example, you set up a pod here, that pod is crashed due to some reason. This controller manager responsibility is to, it's just like a loop. It's a piece of code. It's just like a loop and running after every some time, and it is asking API server after every some time, okay, give me the status, okay, give me the status, okay, and it is comparing that status with etcd. Mean, if I give you example, you know about the conditional statement, if condition. In the if condition, what is happening? There are two variables. This variable is equal to this variable, then do this. If this variable is not equal to this variable, then else body will be executed. Okay. So in the condition statement true case, it will do nothing. But in case the etcd database key value is different than the acknowledged by the API server, it will perform else, and that else will regenerate, this controller manager will ask API to set up, I need this number of pod because it was requested by the admin. So you have to recreate these pod because these pods are deleted. These create these number of resources because these are deleted. So this is the purpose of the controller manager. Controller manager is doing a huge, working in a huge domain. Controller manager I wrote here. Locally, each controller is a separate process, but to reduce complexity, they are all compiled into a single binary and run in a single process. Actually, the controller manager loop example I gave you, the code that is running after every uh, specific number of time, amount of time, it is taking care of deployment, replica set them, and we don't know about these services, but it is
Excuse me,
checking
sir.
the status of these services.
Excuse me, sir.
Gigi, please.
Yes, good, good. Sir, controller manager will not perform the action on the pod man. Scheduler will perform the action.
Sorry, will not
Controller
perform
manager
where?
will directly perform the action and not directly talk to the scheduler. And a controller manager will tell to the API manager that it will talk to the scheduler to create a new pod or anything. Action will be performed by the scheduler.
Controller manager will ask, when as an admin, you send the manifest to API. Okay, and API asks the scheduler, and scheduler API setup asks the kubelet, and kubelet did its job, and then it is recorded in the etc. Same thing will be done by controller. When the desired number of pod is not there, it will send the request to API. API will ask the scheduler, and then again the same process and will be recorded to the etc. and
But
desired number of.
but controller manager will not directly talk to the scheduler. All the
No, no,
action
no.
will be performed by the scheduler.
Yes, scheduler is a
Okay.
different component, only reachable by
Okay.
API. So
Okay.
this API server is the core engine, center point
Okay.
of communication in the Kubernetes architecture to make all the functionalities and communication of the master
In the
node.
Kubernetes architecture, it is seen that the controller is not directly perform the action. The action is performed by the scheduler through the API server.
No, no, action is performed by the API.
No, the action is performed by the scheduler.
No, no, scheduler is just providing you where you have to. You can bypass the scheduler. You can stop the schedulers, even though we have the way to schedule the resources.
If in any pod the container got some problem and some error or it is not working properly, podman will directly tell to the kubelet,
No.
the container engine,
Yeah, yeah,
uh,
it
con-
will. The kubelet knows every time what is happening. Yeah.
kubelet knows that one
Mm.
container is get down and it will tell to the API server, and API server will tell to the controller manager. No,
No.
the API
No.
server will go to the etcd
No.
for the key value.
No.
How?
Pod is crashed. Okay.
Okay.
Controller
Not that pod is
manager.
crashed.
For
Not
example,
pod is crashed.
pod is crashed. Okay, pod is crashed, no problem. Now
Okay.
controller manager ask after some time to API tell me the status of the cluster. API manager ask all the kubelet. What is the status? One worker node told that I lost this pod. So in
Okay.
that case, controller manager will compare that value with the etcd. Whatever is written in the etcd should match with the exact number of worker node ports. So that when that difference will happen, in that case, it will again generate the request to API to schedule this now. Because API is just is doing whatever you will ask him to do. As
Okay.
an admin, you ask him to perform this action, it perform. It
Okay.
cannot do automatically. It needs some language manifest that will be implemented.
Okay. That way, that manifest can be YAML or that can be JSON. Because through JSON or YAML, you can use that.
No, only YML. JSON is
Wow.
I don't know. It's not readable by API. It can only understand YML or
Okay.
by the command line utilities.
Okay.
So controller manager is basically taking care the health of all the services running. Okay. And basically in the Kubernetes, we have controller of type deployment, replica set, daemon set, service job, cron job, endpoint, stateful set, lot of other controllers are available. And all those controllers health is managed and take care by this controller manager. Okay. So now you got the idea how controller manager is again. Now here we have only one master node. So when we will set up the multi-master, so we'll set up the three multi-master. We can set up 1, 3, 5, or 7 or odd number. Because the election is going to happen, etcd will run where exactly? I think controller manager scheduler API can run at the same time, but etcd can is a type of database. And like the example I gave you, the database, only one database will work as a master. Rest of all will work as a slave. So there will be an election happen among all the master node, which etcd will perform as a master. So for that reason, they are using the odd number of master nodes. So we will start with the one worker master node, and then we will also set up with the multi-master. So when you will set up the multi-master, you need a load balancer on top of master nodes, because the admin will not then directly communicate with the master node. It will send the request to the load balancer, and load balancer will route the traffic to API server. Okay, so now you understand all these boxes. Okay, now this one is less. C advisor is basically Indian. It is not by default available. You can install it. We will do. Uh, C advisor is container advisor. What is the CPU, RAM, disk IO, network IO? What command I wrote here? The Docker stats. This command, you remember we used. So CPU, memory, network, block, IOPS, everything will be fetch and will be reported by in the form of metrics to in the form of metrics, and you can record that metrics output after every specific number of amount of time in some time series database, just like Prometheus. So Prometheus is a time series database. So just like you know about the SNMP, SNMP is basically when you poll the SNMP, it is responding you all these values. Whatever I did here, all these values you can get also by the SNMP. But for the microservices, we are not using SNMP. We are using metrics-based output. I will show you when we will set up the monitoring of the Kubernetes cluster. So, and then kube proxy. The kube proxy is basically just writing the IP table rules when you need to expose some application publicly. I mean, you set up a container. So here what we did, we use the -p switch to expose our service. So if I do a netstat -entub, and you can see right now no container is running. I think I can docker run -t-p. This port is managed by a Docker proxy service. Actually, this port is now open for this Nginx container for the external world. You can send request to this port, and that port will be request will be routed to. So actually, this whole job is done by Docker proxy engine. So if we go to the Kubernetes, there is a kube proxy. So they are not using the container Docker or any container runtime engine based proxy. They are using their own proxy. So you will, as an admin, you will ask API, I want to expose these ports on pods only for the external world with this port number. That will be exposed on all worker nodes. And on any worker node, when the request will come, will be routed to that specific pod. So this kube proxy responsibility is to make the communication to the external world, and this box is showing the end user apps and services using K8s cluster. So whatever is running inside this cluster as a service will be exposed. This is the end user, this is the administrator. Okay, you got it? Now, last thing, how this pod is going to communicate with this pod. There is an underlay network. So just like when you are setting up your physical infrastructure, you will purchase the switches and routers. So what vendors you will use? You can use Fortinet, you can use Cisco, you can use D-Link. There are a lot of vendors. So you will decide what vendor switches you are going to use to make the communication of your servers and how your servers will talk across the different offices by using VPN or whatever protocol you can use to secure. You can use BGP protocol, or there are a lot of things. So it's up to you. So similarly, Kubernetes is asking you, you can bring your own software-defined network layer from any vendor that will make the communication of these pods to across the different hosts. What we did here, this was a virtual switch. This virtual switch is connected with these pods. Okay, this is communicating. In this case, in Kubernetes, we are not going to use the virtual switch created by container runtime engine. We will depend on a third-party network-based solution that is also known as SDN, software-defined network layer, that will responsible to provide the IP and the connectivity same like this to each pod. With the DHCP, it will provide the DHCP by the IP, the host name resolution will be provided by a DNS, not by this network switch. So ViewNet and Flannel and Calico, these are some examples we can use as a third-party products that are integratable by Kubernetes to provide the underlay network to make the communication among different pods. Cilium is also a new, not new, but most of the people are using Flannel or ViewNet or Calico. So we also have to deploy this underlay network that will make the cross. And what this network will do, this will make a static route on each worker node. And you will provide to this virtual network a big subnet, just like you provide 10.000/8. So now this network, ViewNet or Calico or whatever vendor you will subnet this big subnet /8 to small parts on each worker node, and will deploy a switch on each worker node with that specific subnet. So each worker node will have its own switch with own subnet. And how they will communicate with each other, there will be a VXLAN tunnel, the VPN based tunnel, you can say, among all worker nodes. So the both switches, all the switches across the worker node will communicate with each other. And each worker node will, I will show you a static route is added. For example, I have 10 worker nodes. So how this worker node 1 can reach to rest of the 9 worker nodes? It will have a route to route the traffic to different subnets. So now, if you look back to the roadmap I showed you, gave you in the group of in Notepad, I wrote the strong network concepts you should have to be a DevOps engineer, a platform engineer. Why this job is so much paying you this amount. I mean, as a normal system administrator is not getting this much amount in the market, but a DevOps engineer, because you are working as a system engineer, as a network engineer, as a security engineer, okay, and the infrastructure engineer, all the jobs you have to do. Now they are dividing these all the responsibility with platform and DevOps engineer. They are doing different jobs. A platform engineer is basically taking care of all these networks. So, but in small organization, you should know. So if you are not good with the network concepts, with the subnetting, IP addressing, CEDAR, routing, switching, up to layer 4 at least, you should have a deep concept of the network communications. Then you will get the idea how this whole story is going on. And this ViewNet is not, this virtual switch will also be on the controller node. I just showed here the worker node, but it will, this net SDN will span across all the nodes, including control node. So this was the whole story. Now your questions, if you have any.
Okay, in start we were creating just containers and we were looking into the containers, but now and onwards when we will talk about the Kubernetes, we will not name any of the container, but we will create the pod and then we will see that how many containers are in the pod. How do we, creating the pods, do we need to create the container first and then we will define it in the pod? I mean, how this will proceed?
This will be just admin wrote the manifest. It asks the API to, I need this pod. The API will ask the scheduler. Scheduler will tell that, okay, go to that worker node and ask kubelet to set up the container, and the kubelet will set up the container.
Container or pod?
Container, actually it's a container. Pod is the name. Actually in Kubernetes, we will, at the end of the day, container is running, but we will access container as a pod.
So when we talk, I mean, it's pod, definitely there would be a difference in commands as well, that run pod, stop pod, something like.
Yes, it will be. Because we are not interacting with this container runtime interface. We are not interacting with this one. We are interacting with API. So we need to, so far we understand the language of Docker, Docker run, Docker execute. That was the language of Docker. Now we have to understand the language of API.
Okay.
Anything else?
Yes, I have one more question. For the pods, for example, we have thousand spot in there, and I want I in my organization we have the own autonomous system as well. So and the eBGP is working as well. So so which layer basically where we have to configure the eBGP protocol, so that's communicate to all pods, and they will route. For example, let's say in thousands we have 10 or 20 pods are accessible worldwide, and they have the public IP. And also I need to do the eBGP and the iBGP. So is there any device there that will communicate and plays as the router or something like that?
eBGP actually, you are giving example. I think you have a big infrastructure, you have different offices, and they all are using on-prem Kubernetes. And on-prem Kubernetes, they hosted the Kubernetes cluster in different offices, and all offices are connected by eBGP. This is your question?
No, no, no. eBGP, let's say we have the pods
Ah,
run
you want to expose the pod directly by eBGP.
yeah, yeah,
BGP, yes, this is
yeah.
possible. For that, when you can you do the eBGP with D-Link?
Sorry. Hey,
Can you do the eBGP with D-Link?
with the D-Link with
No,
the
we cannot.
we cannot.
No, we cannot. Simple. That vendor is very simple. That is providing only layer 2, layer 3, layer 4 functionality. Okay.
Yeah.
Okay. You will buy some big vendor product as a Cisco or F5 or just like this, a Fortinet.
Yeah.
So in that case, you will change this plugin, network plugin, also with that SDN that supports the eBGP. eBGP is not by default supported by Flannel, ViewNet, or Calico. I gave you example. eBGP is supported by Cilium.
Okay. Okay. Yeah.
So
No,
same, just think like you have multiple offices. The multiple offices, each office has a data center. Data center has a rack. Now you want to make the communication. How you will make the communication? You will create this. You will make the switch. You will make the gateways. You will make the routing, static routes. So all these things you have to take care uh, while making this physical infrastructure. Same thing is now coming in software-defined network. Your router, your switches, your VPN, everything is going inside your software-defined network.
Okay. And for the pods internally, we can also use a routing protocol, or we will use the static, or they will
No, no,
do
no.
it.
Pod will only get an IP and gateway. That is the end of story. Now, if that pod want to reach somewhere, that pod will send us traffic to its gateway. Simple.
Okay, I got it. I got it.
Main pod responsibility is to run the service, not the taking care of the network. So pod it will route the traffic only.
Thank you,
Anything
Asif.
else?
Yeah, thank you.
Okay, if you are good, we can close the session, or if you have any question. This is also an architecture, but this is a cloud-based Kubernetes deployment architecture. So far, I gave you the architecture about on-prem. So when you are going in cloud, things are same, but there are additional controllers deployed in the Kubernetes cluster by that specific cloud provider. What is the reason we will discuss when we will deploy this Kubernetes in cloud?
So to start with this, we should have one master node and one worker node, right?
No,
In
two
the
worker
start,
node.
two worker nodes. Okay. So we should have three virtual machine to start with.
Three virtual machine, each with 4 GB RAM at least and 2 CPU.
Okay.
So in the next session tomorrow, we will install the Kubernetes cluster. So I will just bring the 3 virtual machines, Ubuntu, and on top of that, we will set up the Kubernetes cluster and we will make an interaction from admin to this cluster.